In this lesson, we need to firstly give the multiple regression. Okay? Firstly, in order to build the multiple regression model, we have the more than one input value. Okay? We have three inputs, x1, x2, and x3. For example, 1, 0, 1, 12, and 5, and 3, 4, for example, 5, for example, 100, and it goes on. Okay? And so, in this case, we need to propose a model based on the what? The hx, which is equals to the theta 0 plus theta 1, x1, theta 2, x2, plus theta 3, x3. Each of the input is related to one of the coefficients of this one. Okay? And also we have the cost function in here. And so this cost function, j is equals to 1 divided by 2n, I is equals to 1 to n, yi minus hx squared. So we can write this one I and yi minus theta, this is a vector, and x vector. Okay? And also the training algorithm is the same. Theta I is equals to theta I minus alpha times dj d theta I. Okay? This is the multiple regression algorithm. Or we can propose the classification problem, which is a special case for the what? For R models. And so the R model is just like the sigmoid one right now. hx is equals to the 1 divided by 1 plus exponential minus theta transpose times x vector. Okay? And so this gives us the 0 to 1 value in the hx. Okay? And so we can create the two class, which one, or in terms of what, the 0 and the 1. Okay? And so the cost function may be utilized to this one in here, either the mean square error formulation, just like this one, 1 to n, and yti minus hxi, right? And so mean j, theta 0, theta 1, theta 2, and blah blah blah. Or we can build the cross entropy function for the classification purpose. 1 minus n, I equal 1, and in the cross entropy function, yi times log hxi plus 1 minus yi times log 1 minus hxi, this one, because we have the exponential term in here. This is a sigmoid function, and so this yields us the utilization of the cross entropy function may yield us to the what? The more stable gradients. Okay? And so the training algorithm is the same, because we change the what? The R cost function, theta I is equals to theta I minus alpha dj d theta I. This is the stochastic or gradient descent algorithm. Okay? So these are the notes, and so we can save the notes in here, just like this one, and after that we can build the R network and the Python implementation for this data. Okay? So in order to write the code I open the Visual Studio Code and I generate the V2 training in the first place. Train, test, data, set, generation. For the what? For the hold out and the what? The cross validation method. Okay? And so, in order to build this, we need to import the numpy smp and import matplotlib pyplot as plt in order to draw our dataset in here. And so from learn model selection import train test split and k fault method. Okay, first of all we need to generate the random data. Okay, so in order to be randomized our data, seed value is changed, for example the 0. Okay, and after that x can be created with what? mp random function and rand function with what? 200 data and 2 features is given in here. Okay, 200 data, but x1 and x2 are generated in here. And also y is assigned with what? This is the output of our algorithm. It's the arbitrary value and whole term first feature plus x second feature if greater than 1 and s type integer. This creates the binary labels based on condition, right? The condition is that if is greater than 1, which is equals to the 1, otherwise it equals to the 0. And so how we can apply the hold out method? Train and test data. First of all, the xtrain, xtest is assigned ytrain, and ytest can be built with what? The train test split data. X is the input, y is the output data in here. Okay, and also we should give the test size 0.2, which means that 20% of the data are splitted into the what, or the purpose of the test. The otherwise 80% is used to what? To train. Okay, and also we randomized our state with the 42. Okay, and so also we can utilize the k-fold dataset or cross validation technique in here. Kf can be built with what? The k-fold function and splits is equals to 5, which means that we generate the 5 subset to what? To evaluate the r, x and y value in here. And also shuffle means the shuffle the r dataset is true and random state is also assigned to 42. Okay, and so we have 2 datasets in here just like this one. And so how we can build this dataset or show the properties of these terms on the figure. PLT figure can be built with what? The fixed size 14.6. Okay, and so for the holdout method, plot subplot is assigned with what? 1 2 1, and PLT scatter is assigned with what? The xtrain, the whole data first feature, whole input data second feature 1, and c is equals to the ytrain. Okay, because it's equals to the what? The 0 and 1, and so we can map the whole data into what? Into the different colors. Okay, c and paired and label can be assigned with what? The training data. Okay. And also we can assign to the what? To the another scattering here, but in this case xtest is given in here. Okay, and also we can give the marker at x, and so this is the test. Okay, so PLT title is equals to what? The holdout method. Okay, it's a randomized method, and PLT legend should be on. So, what about this is the holdout method. What about the kport method? First of all, the fold is equal to the 1, and so for train index and test index can be given in kf split function. Split returns to the what the values of the test and train index in the shuffle form. Okay, and after that, so we need to give the x train in here and x test, just like this one, and so x. But now the train index should be assigned, and x test index is given here. Okay, and also we can get the y train in here and y test. It is given here y train index and y test index. Okay, so we need to draw the PLT subplot in here, just like this one, 1, 2, 2. And PLT scatter, which is given here, just like this one. Training data, and but with a one difference is that this is turned into the what the f fault value. Okay. So after that, we need to write the PLT scatter for the what? For the X test data. Okay? But in this case, this should be assigned to the what? To the gray. Because it's different with what? With the white frame. Okay? And also, we need to give the what? The properties in here, the marker equals to the x. Okay, and at each case fault is increased with the 1, and PLT title is the what? The kport cross validation. Okay, and PLT legend and PLT show. Okay, and so if I run this code, and then we will have the two kind of data set in here. Okay. Yeah, here she has arguments in here. Line 24. I'm sorry, guys. I can correct it. I'm sorry. This is the test, and so this is equal to what? The y test. Okay. In this case, in the holdout methods, we can randomize the holdout data based on this information. The training data is assigned with what? With the gray line. Okay? And the other terms is the what? Is another one. This is the test data. Test data is showing into the what? Into the x, and the other term is the circle in here. But just see that the fault 1, fault 2, fault 3, fault 4, and fault 5 is assigned to different based on this k-fault cross validation. And so we can fit the whole algorithm based on what the training and the test data by using the what? The holdout method and the k-fault cross validation technique. Okay, so this is the preparation of the data on the what? On the model training. Okay, I will share this code also to you guys. So in the second case, we write the linear regression code. .py. Okay, but in order to build this, we need to utilize to the what? Some important library, which we call it the Pytorch. Okay, and so import the matplotlib.pytorch as plt. Okay, and also import pandas as p, and also import torch with the Pytorch library. Okay, and import, we should build the what? The perceptual model based on the NN library, and so import torch.optim. This is the training function as optim. Okay, firstly set random seeds in here, just like this one, mp random seed 42 and torch manual seed must always be set with the what for the different variable generation for both the MP and torch, because these are the separate things. Okay. So data generation should be built in this case. First of all, x MP random runs value is 100 times 10. This generates the what the x values between 0 to 10, because this is the normal distribution which is given with the what, with the 0 to 1 value. If we multiply with the 10, and so we will get the 0 to 10 values in here. And also we should add the noise value in here, just like this one. MP random normal distribution. This is the normal distribution with the mean and standard deviation value 0 mean and 5 standard deviation 100 point, which is given in here. And also y is the output vector, is a training set 7x plus 5 plus noise. This is the bias term, and this is the what, the theta one or the tangent term in here, but we don't know in the first place because this is the data generation for the what, for this case. For example, the plot the data with training plus, okay, and so the PLT scatter x and y, and label should be given in here data with noise, okay, and also opacity is set with the 1, and PLT plot x 7 times x plus 5, and color is assigned with the red, and label is the true line, which is equals to y is equals to the 7 times x plus 5, okay. And PLT x label is assigned with the x, and PLT y label is assigned with the y, and PLT legend is assigned, and PLT title is assigned with the random data generation in here with the noise, and PLT reads true, PLT show. Okay. And so if I run this code, and then we will have this blue dot is our training data. This is the y and this is the x, okay. And so we need to build this red line in order to what, or coming from the what, the learning algorithm based on the what our NN tools, okay. And so how we can do that? First of all, we must see that we need to generate and save and load data using pandas. This is important property because in the case of your real application, you have the data in the Excel file. PD data frame can be written just like this one. The input x, okay, and x, it's the output y, and this is the y, okay. So data to Excel is a file to what, to linear regression data, linear regression data XLSX, okay. And so index is equal to the what, to the false, okay. And so if I rerun this code, and then we will have this XLS values, okay. And so this can be seen just like this one, okay. The input and output data which is given in here. And so in the real life example, you have this Excel file, but in our case we don't have the Excel value, and so we generate the random data set just like this one, okay, for the purpose of the what, our examples, okay. And so how we can load this data set? The loaded data is given with the PD, and read Excel file can be used in here just like this one. This is the linear regression is ls file, okay, and x loaded is assigned with the loaded data but with the input x, okay. And so to numpy, it's important we convert the whole values into the what, into the numpy, okay, array. And so y loaded is also given in here, and so this is the output y to numpy, and also we need to print the what, the loaded data, in order to be sure we get the whole data in here, loaded data and hat, okay. And so if I run this code again, and so we can also have this kind of data in here, just like this one, okay. So how we can build or prepare the data for Pytorch implementation? First of all, we need to create an X tensor in the Pytorch. Torch tensor should be built with what, the X loaded. The type should be given in here, torch dot float 32, okay. And so wheel should be called in here -1 and 1. This is the what, the dimension of the what, R tensor dataset, okay. And also we can give to what, to y tensor, and y loaded is created just like this one. And so after that we need to define the linear regression model in Pytorch. But how we can do that? The model is built with what, the NN linear 1 and 1, which means that one input, one output in this case, okay. So in order to fill our dataset with torch, no-grad is a special function, which means that we don't calculate the gradient values of this torch by using this with keyword. And so the model weight fill, this is the initialization of the coefficients of the R model, for example the 2.0, and this is the weight. Just remember, this is the what, the theta 1 value, and also we have the theta 0 term, right? But this is the bias, okay. And maybe this is the 1. This is the initial values of these terms, okay. And after that, just like in the R case, we need to define the loss function. In the Pytorch, we can build the criterion in here, NN MSE, mean square loss function in here, okay. And also we need to give the optimizer in terms of the what, the stochastic gradient descent. And so we need to fit the model parameters in here with the specific LR, learning ratio, just like this one. LR is equals to what, 0.01, okay. And so this is the basic initialization of the R algorithms. And so how we can train this algorithm, training loop. This is built with what, the num epoch, which is equals to the 1000. This is what, while up to, in this code, just see that this summation is what is replaced with what, the epoch number. If the epoch or the while loop is up to the what, 1000 loop, and then the R algorithm or training path is done, okay. And so for epoch in range of num epoch, model train should be called in here. This is the training class, okay. And so optimizer should be set with the 0 gradient values, okay. And after that, the output should be obtained with the what, with the model in terms of what, the X tensor is fed in here, just like this one. And so the loss must be calculated with the difference between the output and the Y tensor, okay. So loss should be backward in here, and optimizer is set for the another step, okay. This is the what, this is the training loop for the R algorithms. And after that, how we can evaluate and plot the test results in here. In the first place, we need to turn the model into the evaluation mode by calling the .eval function in here. And after that, with torch no grad should be called in here, which means that we don't have any gradient computation in here. And ygrad, the prediction values, x model, x tensor should be given in here, and numpy, this is the conversion method, and flatten, we need to flatten all the data by calling these functions in here. Okay, and so to ensure the regression line is smooth, short the x values and corresponding prediction, because we shuffle the whole data in here. And so shorted in this is equals to what? MP argument short x loaded. Okay, x shorted is pretty much like x loaded shorted indices. Okay, and ygrad shorted must also give the ygrad shorted index. Okay, this is simple because if we have this information, and so if we shuffle the whole network, and after that we need to normalize or turn into the back the order by using this short algorithms. And after that we need to plot the whole data, PLT scatter, x loaded is given in here, y loaded in here, and also label. This is what the data with noise. This is a training data. Okay, and alpha is equal to 0.7. Okay, and PLT plot must also be used in here, x sorted, and also ygrad sorted, and color green is assigned in here, and label is equal to the what? Regression line, and line white is equal to what? 3, and PLT x label is input x, and PLT y label is the output y, and PLT legend should also be called, and PLT read true, and PLT show. Okay, also PLT title, this is the linear regression in Pytorch. Okay, so if I run this code, in the first place the random data generation based on what? This one, and after that I'm sorry, in the fifth line we don't have the linear. I'm sorry, this is the big. Okay, right now 59 the model parameters. I'm sorry guys, this is the parameters. Okay, and so after that 69 numpy. Okay, in this case, see that if the R algorithm is trained in here, and so this gives us to the what? To the green line in here, just like this one. Okay, after the training class, this green line is built with the what? With the R trained class. Okay, and so the regression line is created by using this term. Okay, and so our model is worked perfectly, but we cannot reach the, for example, the print loss function can be called in here, and also epoch number is given in here, just like this one, loss and apple given in here. See, in this case we have the tensor values in here just like this one, and so the loss, I'm sorry, this the loss dot item should be falling in here. See, our algorithm is trained for the what, for this algorithm in order to this build the model, but the loss is not going to the zero. Why? Can anyone answer that? The green line is our model, but the loss cannot be going to the what, going to the zero. Why? Because in the linear regression we have the noisy signals in here. See, and so we can only model in the linear model just like this one. We cannot model this dot or this dot, but also we converge or approach the maximum optimal values for a given the regression line in the Pytorch implementations. Okay, for example, if I change the what, this STD value is equals to the 2. Okay, and so if this 2, there, see that the noise is decreased in here, and so see that the loss is diminished or decreased in this case, right? And so this linear regression is more perfected in this case. But the other case, we have a data that we cannot model based on the linear neuron representation, theta 0 plus theta 1 x. Okay, these are the case for the what, for the linear regression. And so in order to build multiple regression algorithms, now we need to build firstly the libraries as the MP and import matplotlib.pyplot.splt and import pandas again spd in order to write and read the data from the Excel file, and also import torch nn snn and import torch optim as optim, and from learn matrix import to the mean squared error. Okay, firstly just see that set a random seed in here, mp random seed 42, and torch manual seed should be assigned to 42. Okay, and data generation must be done in here. First of all, the x1 is equals to the mp random values rand 100 data times 10 up to 0 to 10. Okay, and also we can generate what to the x2 10. Okay, and also we should give the noise in here just like this one, the noise mp random and normal values with the 0, 2 and 100. This is the expected mean value, this is the standard deviation value, this is the 100 data. Okay, and so y, for example, 7 times x1 plus 12 times x2 plus 5 plus noise. And so after the training, the bias must equal to the 5, the tendency or the tangent vector is equals to the 7 and 20. Okay, and so how we can show this diagram? First of all, figure is equals to the PLT figure. Okay, and so x is fig, x subplot is a properties of the 1, 1, 1. Okay, and so the projection should be given in here just like this one in the 3D form, because we have the x1 and x2 data, and also we have the output y, and so we have 3 dimensions in here. And ax scatter is assigned x1, x2, and y, and label data with noise, okay? And alpha capacity rate of the watt 0.7, ax dot set x label is assigned with the input x1, and y label input x2, and ax set z label, and so this is the output y, okay? And so PLT legend and PLT title is assigned random data with noise, okay? And so the PLT grid should be given in here, the true, and PLT show must be given in here, okay? So if I run this code, and then we will have this kind of data distributions in here, okay? And so how we can see that this is the x2 and x1, and so we have the hyperplane just like this one, but with a noise signal in here. And so we need to build a machine learning model based on the multiple regression model, and so we will have the hyperplane in here, okay? But how we can do that? First of all, just like in the previous example, save and load data from Excel, okay? And so data is equals to what the PD data frame can be converted into what as what the dictionary values of this term, input x1, okay, x1, and also input x2 and x2, and also we should give the output y and y, okay? And data to Excel file is with the with the name of the multiple regression data XLSX, okay? And the index is equals to the false, okay? And so if I run this code, and then we will have to the Excel file, okay? But in the in this one, the Excel file linear regression and multiple regression data, which is given in here. See, x1, x2, and y are. And so we need to read this data from the from the Excel file, and after that we build to the to the R algorithm, okay? So how we can do that? The loaded data is given with what the PD read Excel, okay? Multiple or this XLS file x in here just like this one, and so x1 loaded is equals to what the loaded data, and so with the parameters of the x1 and 2 numpy must be called in here, okay? And so this is the x2 and this is the x2, and this is the y loaded, and this is the y, but this is equals to the r, okay? This is the head. After that, print loaded data can be given with the with this one, and so print loaded data head, okay? So if I run this code, and then see that input x1, x2, and y are seen on this page, okay? So firstly, in order to create our model with the multiple regression model, we need to combine x1 and x2 into a single input array by using the column stack. Combine MP column stack, and so x1 loaded, x2 loaded, okay? And after that, prepare data for Pytorch. Okay, x tensor is equals to what? The torch tensor x combined with what? With the type of the torch float 32. Okay, and also this is a single input array. We don't need to use the v function in here, but for the y tensor we need to give the y loaded, and also view should be called with what? Minus 1 and 1. Okay. So after that, define the multiple regression model in Pytorch. Okay, so model should be built with what? N linear, but in this one 2 and 1. Okay, and so 2 weight, 1 bias. Okay, and so with torch dot nograd should be called in here, and so model dot weight copy is another function to initialize our network with the what? With the torch tensor. We have the two values here. For example, 1.0 and 1.0. This copied into the what? Into the weight. Okay, and also we have the bias value in here, but in this case the bias is assigned with what? The 2.0. This tensor is copied to the what? The bias values. Okay, and after that define loss function and optimizer, right? Criterion is equals to what? NN MSE loss function, and also the optimizer is set with what? Optim stochastic gradient descent model dot parameters, and learning rate is equals to 0.01. Okay. So the training loop also given here, just like this one. Num epoch is equals to 1000, for example. The for epoch in range of num epoch. Okay. Model train should be opened in here. Optimizer 0 grad should be given in here, and the output is equals to what? The model x tensor should be provided, and also we have the output of the R model. The loss criterion should be assigned with what? The output and y tensor. Okay, and loss backward should be provided. This is the gradient update for R optimizer, and so optimizer step should be calling in here, and also we should give the what? This epoch function. Okay, so in this case we set the whole algorithms in here. Okay, after the loss function. So this is the training loop, and after that we have also evaluation loops in here. First of all, with torch no grad should be called in here, and yprat is equals to what? The model x tensor numpy. Okay, after that MSE, the mean square error, can be calculated with what? The y loaded value and yprat. Okay, and after that we can print the what? The total or the last mean square error value as the what? MSE dot UF. Okay, here. After that we need to draw the figure. First of all, the fig is equal to what? The PLP figure, right? And the AX is the axis figure pick at subplot as the 1 1 1. The projection must be assigned with the 3D. Okay. AX scatter values, the x1 loaded and x2 loaded and y loaded. This is the trained data, training based. Label is equal to what the data with noise, right? And opacity values is the what 0.7. Okay. And after that, we need to create the mesh grid for regression plane in order to prove the R algorithm. X1 plane and X2 plane should be assigned in here. MP mesh grid is assigned to MP linscape, linspace with what 0 to 10 and with the values, and also MP, the same one should be assigned in here for the creation of the mesh grid. Okay. The next plane should be assigned MP column. Stack should be called in here because we have the x1 plane variable function should be given here. This is the function of what the array to stack. All of them must have the same first dimension. Stack 1D arrays as columns into 2D arrays in here because we need to create the hyperplane in here. Next 2 plane is equals to the what? The variable function. Okay. So convert the mesh grid data to tensor and predict the model. Okay. Explain tensor is equal to the what? The torch tensor because we need to use it in here. Explain and dtype torch plot put q. Okay. And so with torch nograd should be called in here for the evaluation. Y plane can be created right now with the model of the x plane tensor. Okay. And numpy should be called in order to convert to this one, and also reshape function should be given in here in terms of the what? In terms of the x1 plane shape or dimensions. Okay. After that, plot the regression plane. Okay. AX plot surface is assigned to x1 plane, x2 plane, and y plane, right? And C map, which is equal to viridis and alpha opacity rate 0.5. Okay. And AX set X label is input x1. AX set Y label is equal to the another feature x2, and AX set Z label. In 3D dimension, this is the output of Y. Okay. And PLT legend should be given in here, and also PLT title Pytorch result. Pytorch multiple regression. Okay. And PLT grid true, and also PLT show. Okay. So if I run this code and then there is no error, syntax error, so the loss is diminished, and see that this is the R hyperplane. Okay. And so our hyperplane is matched with the what? With this data. See, our match is good in here, just like this one. You can see that. And so, in order to understand this code, you need to study our code in here. This is a demonstration or the visualization of the R algorithm, but this is the same looks in here. That's it. Okay. So let's stop them. We need to also build the classification problem in here. Okay, as always we do import numpy smp in order to matplotlib pyplot as plt, import pandas as pe, import torch, import torch nn, import torch optim as optim in order to evaluate the training algorithm and the loss functions in here. And also we have some special case in here, torch utils. This is the useful function for the data for what to import data loader. This is a generalized method to what to import our dataset into the Pytorch. And tensor dataset is the similar way to what, unlike the linear or multiple regression one. Okay, these are the useful dataset and the professional dataset or the code to utilize these two functions in here. And also from scikit-learn metrics import, we need to use the mean squared error and also accuracy score. Okay, first of all the set random seed for reproducibility, and here random seed 42, and torch must also should be seeded with the 42, and data generation should be given in here, but for two cluster values. In order to create the two cluster, MP random normal values should be assigned within here, and so the location or the mean values is assigned to what, the 2 and 4, x1 2, x2 4 for one class, and so the scale or standard deviation is equal to the 1. And also we can build the size of the 102, which means that we have the 100 row and 2 columns in terms of the x1 and x2. Okay. And also we can create another cluster in here just like this one, 8 and 6. Okay, x is equals to what, the mp we stack. Okay, this we stack should be provided with cluster 1 and cluster 2 as a tuple. Okay, and so y is mp concatenate, which means that we have first of all the mp zeros 100, which means that in this case the first class is assigned with the 0 and the other class is assigned with the 1s. Okay, and so in order to train the algorithm we need to shuffle all the data. And this is equals to what, the mp arrange x shape. This is the dimensional return values, and mp random dot shuffle can be called in here in this is. Okay, and x is translated with what, with this indices, and y is translated with what, with this indices. In order to stabilize our training algorithm, we need to shuffle the whole data in here, just like this one. Okay, and so the scatter plot for this class, and so plt scatter can be called x is, for example, y is equals to 0 in these conditions. Okay, these values, and x y equals to the 0, and also 1, and label is assigned to class 0, and alpha is equal to 0.7. Okay, and so we can copy all of these terms, the scatter, but right now the y1 and it's the class 1. Okay, and so plt x label this is the feature 1, the plt y label, and this is the feature 2. Okay, plt legend, plt title, random data for binary classification can be seen in here, and plt grid must also be true, and also PLT show can be seen in here just like this one. And so if I run this code, and then we will have I'm sorry, that's it. Sorry, there is a loader. This must be Rage. Okay. See, we have two classes. One classes which is given in here 2 and 4. The other classes 8 and 6. Is the distribution of the what, the standard deviation, and the mean values of these terms. And so how we can classify these two terms based on the what, the Pytorch classification or the perceptron model in this case. Okay. So in order to copy this algorithm, because this is the same with the previous one, data, PDF data frame to Excel, and loaded data is assigned feature 1, feature 2, and load headed is given in here. Okay, and so if I run this code, we have the classification data in here, just like this one. See, this is the classification data. Feature 1 and feature 2 is given here, and output is 0 0, maybe 1 and 1 0. See, this is the shuffled in here. Okay, so we need to prepare the whole data for Pytorch. Okay, X tensor is equals to what, the torch tensor X, and D type torch float 32. Okay, and also Y tensor is also given in here just like this one. This is the Y, is the type of the float, and wheel -1 and 1, which means that this the shape is equals to what, the n samples 1, which means that we have 200 data, 201 comma 1. This is the representation of the distance. Okay, and so how we can build the dataset? Dataset can be loaded in here. Create a data loader in here, which is useful for mini patch algorithm. You need to search on the internet for the mini batch training. Okay, and so dataset can be built with a tensor dataset, an X tensor which is built with the Y tensor. Okay, and so the loader can be built with the data loader dataset. Okay, and also we can give the batch size in here 32, and shuffle is equals to the true. The batch size means that at every 32 samples are gradients updates. If we don't use this batch size, for example, if we have 200 data, whole 200 data gradients are calculated, then updated our algorithm. But in this case, in this batch size formation, and so 32 data can be calculated by using the loss, and after that the gradient is uploaded, and so the gradient can be organized, or the convergence can be fastened before this linear or the multiple regression one. Okay, so model definition should be given in here just like this one, the model, and then sequential is a terms on the and then given here comes as an given here. Okay, and a sequential can be given with the linear 2 1, which means that we have 2 input and 1 bias value, but after that we need to utilize the sigmoid function in order to in order to set the 0 and 1 value at the end of this code. Okay, and so initialize the NN coefficients can be built with the NN init Chevier uniform model for the model 0 times weight. Okay, for the weight we can use it, but for example NN init zeros can be used in the what the model zero bias value. Okay, the bias is assigned to the zero and the weight is assigned to the what, to the caviar uniform formation. Okay. After that, we need to define the loss function, but in this case the criterion is assigned with what, NN BCE loss, which means that this is the binary cross entropy loss, which is given in the R slides. Okay, and so the optimizer can be assigned with what, the optim Adam, which is the another algorithm to train the R networks. Okay, you should also look at the what is the Adam on the internet. Okay, it's the another optimizer for the what, for R algorithm to train the networks. Okay, and so the training loop can be built with the what, num epoch is assigned to the 1000s. Okay, and so for epoch in range of num epoch, and epoch loss is assigned to 0.0, and epoch correct is the another definition, and total is the another definition. And so in order to create the batch size, unlike the multiplication, see that in the multiplication at each epoch we calculate the whole values, but in the classification phase we split the whole the training data set in order to into the what, into the batch size. And so for batch X and batch Y in loader, see this loader is useful to what, to use in the for loop, just like this one, because the batch size is given in here, shuffle tree is given in here. All the feature can be utilized based on this information. And after that, the optimizer 0 grad should be assigned in here, and outputs is equals to what, the model, but batch X value is updated in here, and also loss function criterion is the what, the outputs, and batch Y, right? And so loss backwards is assigned in here. After that, the optimizer step is given in here, and so in each case accumulate loss and accuracy statics in here. The epoch loss plus equals to loss item. At each case we need to collect the whole terms with what, with the batch X dot size values. Okay. And after that, spreads is equals to the what, outputs, which is coming from the what, the model. And so if is greater than equals to 0.5, which means that this is the class 1, right? And so we need to turn into the what, the float value. And also epoch correct is assigned 1 equals plus, this is the prats, which is equals to the batch Y times sum times item should be returned to the what, the correct prediction of the, for a given the batch Y value in here. Okay, and also total plus equals batch X size 0. This is the processed size of the batch. And so epoch loss can be calculated with what, with the total nomination, because it's the batch size. And so the epoch accuracies can be defined with the what, epoch correct divided by total. Okay, and so after that, if epoch plus 1 percentage 100 at each 100 epoch, we print to the what, to this one, the print f epoch is equals to the what, epoch plus 1 and divided by total epoch, no, right? And also the loss can be given with the what? With the epoch loss and 4f, right? And also accuracy can be given with the what? The epoch accuracy. Dot 4f, right? So these are training for us. I know it is long, but it is necessary. Okay. So after that, at 100 loss is written, and the accuracy is going to the what? The 93% and 98%. Okay. So how we can evaluate our algorithm? Evaluation. Model eval should be given in here, and with torch dot no grad, okay, and y prat prop is equals to what? Model fed it with the x tensor and numpy and reshape minus what? Okay, and decision boundary must be given in here for the hyperplane nominations. Y prat prop is greater than equals to 0.5 and class type what? 8. Okay, these are the case for the what? For the decision boundary problem, and MSE is equals to the mean squared error with the what? Y and y prat values. Okay, and also accuracy, total accuracy score can be called with what? The y and decision boundary problems. Okay, and also print MSE and one empty space accuracy in here, just like in this one. And after that, the same algorithm is with the previous one. Is too much, and decision boundary is equals to the 0 and x equals to 1, class 0 and class 1 is given in here, and also the match grid should be given in here for the what? For creating the decision boundary. And so if I run this code, see, the training is done in here, and after that the decision boundary is created in here. See that? In this case, this orange line is created or the discriminated with what? With this hyperplane, which is trained in our algorithm. This is the what? This is the our algorithm hyperplane parameter, theta 1 and theta 2, right? And theta 0. Create to this one. The upper class is class 0, which is given in here, and at the right hand side of this line is the class 1. But what happens if I choose these values is more close to each other? Here 5 and 7 5. See that? In this case, see the R algorithm or the R dataset class 1 and class 0 is closing to each other, right? And so see that the loss function is greater than before, and the accuracy is up to what? The 0.97, which means that the R algorithm performance is decreased because the R class 1 and class 0 is shaken to each other. For example, if I choose the what, the more closely, just like this one, 5 and 5. See, the R algorithm is R class 0 and class 1 is what? Is shaken to each other in here. And so the R accuracy must be what? Lower. Just see that the accuracy is decreased up to what? Down to the what? The 0.82. But in this case, we created this line in here, just like this one, class 1 and class 0, but the decision boundary is 0.12 and the accuracy is diminished with what? 0.82. Okay? And so our prediction model gives us the class 1 in here and class 0 in here. But in the class 0, we have the class 1 data. In the class 1, we have the class 0 data. For example, if I choose the 6 in here, and so our accuracy is going down, just like this one. See, 68 and 7 in here. And so our algorithm split or discriminate these two kind of data, but the class 1 possess also class 0, even if it's seen right now. But the accuracy is to what? 0.69 in this case. So this is the classification example, guys. Okay. So we can use these codes in order to classify, or be it the linear regression, or be it the multiple regression, or the train test data set in the Pytorch implementation. Okay.